Hi everybody, and our research topic is Temporomandibular joint course with Metaverse Experience. We carried on these works in a with professionals and with the dentistry professionals, and also with the university professionals and some of the the experts in this field. My name is Burak Kızılkaya. We work with the dentistry professor with Mehmet, Mehmet Hoca, Saliha Hoca, Aykut Hoca, Bilge is the expert, Damla Hocam and Nergiz Hocam were the university professor, and Fulya Hocam is the dentistry professor as well. First of all, we started these topics because we chose this topic based on the feedbacks coming from the dentistry professor. They told us they are struggling to teaching temporomandibular joint course in their the educational system and with the traditional methods, and we come up with the solution. We said that okay, we can carry on this problems, and then we can start to to find out some of the methods, how we can develop and how we can get it to the the real life in a better, effective, best practices. So in this education, temporomandibular joints is our topics, and it has very complexity in teaching and learning process as well. This complicated of the human part of the body is important and critical for some of the several diseases related to human mouth and dental conditions. It enables the function of these parties, enables the performance of chewing and speaking functions in the human body, and attracts great attention for the dentistry. Due to complexity, it's not always easy to visualize and understand the behaviors of the patterns for dentistry students, and it's not easy for the lecturer to teaching as well. And it has a very critical part that is articular disc. Articular disc is about roughly oval shape and provides gliding action between the temporal and mandibular architecture bones. So for this purpose, we have found the complexity of for this purpose, for this complexity in teaching and learning, we chose this area, and we try to analyze the traditional dentistry education methods. So when we analyze it, we understood there is the textbooks, lectures, and hand-on clinical methods they are working on. So our aim of the study is to enhance the traditional dentist educational program through the use of the virtual reality technology by immersive learning methods. To define the learning difficulties of the temporomandibular joint, to explain the anatomical structure of each component of the anatomical structure, and to design and develop a training environment through immersive technology. So before keep going on this why I want to explain why we need the VR tools for this system, because VR tools gives immersion. Immersion means being enveloped and surrounded safety environment. It supports unlimited source and unlimited scenarios that we cannot easily find in real life. VR tools gives interactivity, the ability to control the events and simulation by the human body movement, and the people can they interact much easily as in the real-time simulation. And also multi-sensory feedbacks. Multi-sensory feedbacks means the students can learn by visual, auditory, and some of the tactile, like doing the jobs and seeing. Everything is in the putting in the memory, not just reading or just visualize. It's all targeting the sense. So with this purpose, we created human body parts and the skulls, and we put the standard healthy position and disorder scenarios. We define it, and we put all the critical muscles and the articular disc, all the critical anatomical structures of the temporomandibular joint parts. And we created the metaverse environment, the different scenarios and different parts. It's fully interactive. It can be opened, it can be closed. By opening, it can be stopped and seeing which position where the muscle is behaving or which position where the articular disc is going and how it's going to interact each other and how all these different kind of the complex anatomical structure doing the same jobs together simultaneously. With this study, what was our research question? Our research question is, what is the teaching complexity first in dental education? We need to target the complexity or, the struggling things, and what are the anatomical structure and identify how they work together. We understood how all get together. We need to understand, and we need to define how we can use technology to ease of learning of this complexity for dentist students and also teaching process, and what is the proposed and instructional alternative we can offer. So what is temporomandibular joint? It has two joints that connects lower jaw to your skull. More specifically, they are the joints that slice and rotate in front of each ear and consist of mandibular, lower jaw, and temporal bone, the side and base of the skull. And it has a complexity as seen on the right pictures. We call it Posselt diagram also, and the mouth has a different pattern when opening and closing. It's not exactly the opening and closing in the same path. It's changing, and it has some of the complexity due to the muscles, due to the a lot of components of the anatomical structure. And also it's quite important because it affects the talking, chewing, yawning, all that kind of our mouth behavior. Creating virtual model on human skull of the temporomandibular joint, and we give the interaction to each anatomical structure, and we create the virtual reality environment we call the Metaverse by the multiplayer used to interact with the virtual model. And we also understood that in multiplayer is critical role, because if one people's getting into the scene is all right, but if 20 students can get in this scene with one lecturer or professor, the professor can start teaching all this process in the VR scene to the students, and to see how the students are reacting, how they understand where they are looking. It's getting quite crucial for this educational system as well. And 3D model, and we also eliminate all the unnecessary part of the human skull just to get the students to focus on what they need to learn, not the confusing with another kind of the structural elements not related to the temporomandibular joint. As seen in the scene, we use the Oculus VR glasses. It has the Meta base, so it supports with a lot of the great potential. The user can move around and can open and close the mouth in different alternatives, can watch, stop, and go back, forward. So it's simulating all of the behaviors of the human jaw. So another point, they can get in the model in a different angle, from inside, outside, rear or back, it doesn't matter, or sides, which point they want to see, or they can get a bit zoom out to see all the the whole picture together. So they can visualize all the behaviors under different conditions from different angles, and it's going to give better understanding of all the system in their mind, because we are targeting the visuals and touching, seeing, doing it, and some of them by the speaking ability of this potential, they can hear, they can speak with their friends, discuss, getting feedback. So it's more memorable point. And also we edit some of the critical muscle location here, not the confusing and putting too much elements to causing confusion. So main point, crucial points, and we try to define really the focus on how to the best practice of learning. So we put in here, there's a Posselt diagram. When they open, close, they see how the human skull is, not the human skull, jawbone is tracking the moving, and then they can see the angles, they can see in which angles it was like a human skull. It's like a physical element mechanism. So it looks working with the mechanics. So we are imitating all of this in a mathematics here. And it has a multi-user in this side. Looking, sorry. Yeah. It supports multiple user, and we use the avatar system here. So you see each person has a name tag on it, and then the other people, when they speak, and they can see they can track the other people's behavior, and they can talk each other, walk and wine together, or look to the disorder scenario together, or ask if he didn't understand about the disorder, he can ask the lecturer, and the lecturer can show it in a real virtual environment scene. And in a conclusion, we come up in this study a very complex anatomical structure of temperamental joint simulation and its experience in metaverse are discussed. In the future, I think this environment and its possible instructional implementation needs to be evaluated a bit experimentally. This study is to show possibility of creating such environment and its possible benefit for teaching and learning and the potential as well as the surgical procedures. And we believe that integrating this system into the traditional training program is going to have several benefits. We got one of my last slides, and I want to show the video of our very valuable, and they're also the contributor of this paper, Mehmet Ali Hoca and Aykut Hoca, and their reaction on our metaverse scene.
We can't hear if it is important.
So thank you for your attention. I will be happy to answer any questions. Thanks so much.
Thank you very much for this effective presentation.